Alright, today we're gonna build the YouTube algorithm from scratch. But small problem, I have no idea how to do that. And as if that wasn't enough of a challenge to build a video recommendation system, I'm also giving myself the challenge to explain what is going on well enough that a non-technical user will be able to understand it. Okay, so first things first, what is the video recommendation algorithm? Well, it's an algorithm that recommends videos. It's not rocket science. Basically, the AI has one goal. When a user goes to the homepage, it needs to suggest 10 videos that it thinks the user will like the most, and then we simulate that the user clicks on one and we will see how much they watch. And we will make it so that each user has different topics that they're interested in, and each video are of different quality, but the AI doesn't know about this. At the beginning, the AI has no idea what anyone likes, but over time it starts noticing patterns. Like, if this one user liked these 4 videos, and then this other user liked the first 3, they'll probably also like the 4th. Okay, that sounded better in my head, but you get the idea. It initially just guesses random videos, but every time it suggests something, it checks whether the user actually clicks on it and how long they watch. So gradually the AI figures out which videos go well with which users. Let's first create some fake users and some fake videos. And we will then set up the homepage so that the user gets 10 videos and they will then click on one of them that seems the most interesting to them, and then they watch for some time. But if we only test this with Bob, we'll never know if the recommendations are good or if the algorithm just got lucky. So I made this dashboard where we can test the recommendations with 100 users at once to see how well the AI does on average. And right now, yeah, it's really bad, but that's just because we haven't trained it yet. So to actually train the model, we are going to use something fancy called embeddings. But an easy way to think about this is imagine that each video has 2 numbers attached to it. The first number is how much the video is about gaming, and the other one is how much it is about science. We could then put this into a coordinate system and draw an arrow from the center to the video. And if we then just do this for every video, then we basically have a map of all of the videos. And when we then have a user, then we can draw a similar arrow that shows how much the user is interested in different things. So if the user, for example, like a combination of gaming and science content, then these videos are going to be a good match. Pretty cool, right? So what we need to do is train the algorithm to learn where it should place each video and each user on the map. And then we basically have a recommendation algorithm. At first we'll draw the arrows randomly, but then over time we want the algorithm to move the arrows until it sees good results. Alright, let's see if we can get a basic version of this working. One important detail that I left out before is instead of just having 2 dimensions, we're actually going to have 64. That means the algorithm won't just learn if a video is about gaming or science, it can discover lots of hidden patterns that we don't even know about ourselves. We have no idea what each of these dimensions actually represent, but honestly, as long as the recommendations are good, then who cares? What we will do is create a simulation where we do this as many times as we want, and then we can see the results at the end. Our hope is that it improves over time. And yes, we can actually see that the algorithm gets better over time, but it's still not good enough that I'm satisfied.
2 hours later.
So after trying out some different strategies, we have now achieved a pretty good watch time. But we still have 2 important challenges left. Because while the algorithm now works fine for existing users and videos, what do we do when we have new users and new videos? Let's try out how it works with new users first. I created another simulation where we can create a new user with some random preferences. And as we can see, it takes a long time before the user gets any good recommendations. And if you have spent any time on YouTube, you know that that is not how it actually works. Sometimes it just feels like you watch one SpongeBob theory video and then that is all you are getting suggested. And that is a much better experience than it taking 1000 videos before your results are any good. So I read a paper on how YouTube is actually designed, and they use some clever strategies to try to easily match the user and the videos. They basically take the last 50 videos that the user watched and then uses that to predict the user's embeddings. And that leads to a much faster learning for the AI. So let's try and implement a similar but more simple system. What we will do is that each time the user watches a video, we will just set their embeddings to that video's embeddings. And then when they watch more videos, we set it to be something in between the videos they watched, but where we give more weight to the videos they watched a lot and less to the videos they quickly skipped. By doing this, we can see it takes much less time before the algorithm learns which video the users like. Okay, great. So now we have 1. A system for adding new users where the algorithm quickly learns which videos they like. And we have an overall system that takes all the existing users and videos and tweaks them so the recommendations becomes better and better over time. Then we actually just have one part left of the puzzle, and that is adding new videos. But wait, one thing I'm realizing now is that I have actually forgotten one very important piece here. Because so far our algorithm only learns which videos that matches well with the user's interest. But we are not actually taking into account how good the videos are. You know, a user might be interested in gaming videos, but we cannot just show them any gaming video. Like, imagine if we showed them one of the new Dream videos. Just kidding, Dream, you can take it. So we need a system where we measure how good each video is and then primarily shows the videos we are confident are good, but also test out new videos once in a while to see how good they are. So what we can do is make a system where we give each video a number between 0 and 1 in terms of how good they are. And when we are then making the recommendations, the AI will take that number and multiply it with how good of a match it thinks the video is for the user. And in that way, we get a number that is the total score of the video. But how does this help us to show new videos? Well, instead of just having a fixed quality score for each video, we can give it a random quality score. So if we, for example, are very sure that a video is high quality, it will sometimes give the algorithm a quality score of, let's say, 0.9, but other times 0.8. But it will never give us a number such as 0.1. But for the videos we are unsure about, it will be totally random. Sometimes it might give us 0.1, other times it might give us 0.99. That means that we will once in a while show a new video, but mostly still just show the videos we know are good. And then the more we learn about a video's quality, the more the quality score will center around where it deserves to be. Okay, so let's build that system and then test it out. As we can see, even with this system, new videos are actually never being shown. And I guess that makes sense because if the video is of high quality, the algorithm still needs to learn not only that the quality of the video is high, but they also need to learn where the arrow should point. Let me read some more of the paper that YouTube wrote about the algorithm. It turns out that they are actually favoring new videos more than old ones, so let's try to implement that. Let's say that for the first 10 iterations, we are going to give new videos an unfair advantage in terms of how often they show up, just to give the new video a chance to compete with the ones we know are good. But after 10 iterations, it can no longer rely on the boost. And as we can see in my analytics, that is actually also what we can deserve in practice on YouTube. Okay, so let's implement this system and see how well it does. If we create a really good gaming video, we will expect that it performs really well for the first 10 iterations where it's getting the boost, and then after that it has enough traction to keep growing organically. And when we test it out, we can actually see that that is what we get. And also, just for fun, I created this diagram so we can visualize what the algorithm thinks about the video quality. And if we then make a really bad video, we expect that it will get some views in the first 10 iterations where it's getting a boost, but if the users are not watching it, then it should be reflected as well. Yes, that is exactly what we see. Nice. Okay, just for fun, let's try to create a clickbaity video where the quality is really low, but the thumbnail is high quality. As we can see, the algorithm initially pushes out the video a lot because it's getting some good feedback since a lot of people are clicking on it. But over time it learns that people are not actually watching it, so therefore it starts recommending it less and less. Okay, so with that we have actually recreated the YouTube algorithm. It can now not only handle existing users and videos, but also has a system for how to treat both new users and now even new videos. And this is of course a much simplified version of the real YouTube algorithm, but I still think it's pretty cool. If you like the video, please consider to like and subscribe, it really helps me out. I have around 700 subscribers right now and I appreciate every one of you and I hope to get more in the future. Thanks, bye.